I'm happy to talk about lecture 8. Today we'll talk about the distributed primitive patterns, design patterns for the distributed primitive APIs we talked about in the previous classes. I said that in the end of last lecture that each API in my system have corresponding code level design patterns. That means when you program with the distributed primitive API, you don't need to do something from scratch. You just follow the design patterns for each APIs to construct, to compose, to integrate, to assembly all the API together. So that means the code structure is stable. You don't need to invent anything new. You just follow the structure to create the system. So that must elevate your programming effort. That must make the distributed programming procedure, this type procedure conveniently. So that's why I want to talk about this issue. For each distributed primitive API, there is a corresponding design patterns, and all the design patterns have a structure, and they are combined together to form a minimal programming distributed cell. I call it two-node distributed system, two-node client-server distributed system. I will show you program step by step, next line by line next time. So for today, we just go through all the design patterns and give you a brief introduction. But I think to understand those code design patterns, to code level design patterns, to understand all the distributed primitive APIs, the most important issue is to program. And we just talking not so interesting, right? So, but I think that just for this lecture, I can give you an overview, and we can go through all the design patterns quickly. You must have seen all this code in the previous class when we discuss all the APIs, because all the API existing in certain code structure, those code have a stable architecture, have stable connection, have stable assembly approach. So that is a code design pattern we are talking about. There is 13 distributed primitive design patterns, the distributed APIs, but there is 15 code level design patterns for them. Because for the first one, let's start from this one. For the first one is I call it the starting point. Each distributed system should be started from the main method, right? Because I program with Java, almost all the code have a unique entry and exist. That is a main method. But we are now program a concurrent system, distributed system, concurrency system. So how to create such a program the code that is a unique entry and a unique exist, that I can show you here. You can just follow this pattern to create the code. Because this is an entry and exist for distributed system, such that there are no particular API. So it's entry that exists. This design pattern has no corresponding distributed primitive API. So you can see here although we have 13 distributed programming API, but the pattern number is more than that. The first one, starting point, SP, is one that has no corresponding API. Another one is notification. We also talk about that. Notification is one, when you program notification, you need to follow the code structure or follow the pattern. And the request response. This is another pattern. When I name the pattern, I use the same name as the API, so it simplifies for you to remember all the API. But both of them using the same API. When the request response and notification, both of them need to implement or extend or derive the server message. So here you can see there are just one distributed pattern API, but there are two patterns, right? Two patterns. One is notification, another request response. The code are very similar to each other. You have seen the code before. And this is another one. Right? There is no pattern, and no API, no corresponding API. This is one API for two patterns. Two patterns have one corresponding API. So the total number, because the primitive is 13, right? However, we need to plus 2, right? So the total numbers of code level design patterns or primitive design patterns is 15. This is the code. This is a simplified code, not the real code. But when you program the real code, this you can also call it pseudocode. Here, pseudocode. When you program the real code, there are some boilerplate code here. So, for example, catch exceptions through some exception and some other definition or declaration or something that some syntax require code, but all the code does not relate to the kernel idea, the kernel, the K idea, the K concept. So I just remove all the boilerplate code. So this code here, I can also show you the real code here. The real code. Open this project. Open this project here. Okay, you can see this is the real code. You can see here the real code is more, is a little bit complete, but the essence of the code is the same. So here, some boilerplate code exists, right? Here, boilerplate code here. I also print something on the screen. So this code a little bit complete, but it's for a programmer, for either programmer, for Java programmer, this is easy to understand, right? So here, this is entry and exist. First, we need to start the server. This is starting point. Starting point is a pattern that's the entry of any distributed system in my programming paradigm. First, you need to start it. Start it here. And then there is a while loop here. Here is a singleton exist. The singleton is a signal. We can understand the singleton. You can see it. Its name of the singleton is a terminate signal. That is the unique value for all the process. When the server side is shut down, this terminate signal is changed from the state of the terminal signal is changed from running is changed to terminate. That means the system shut down. This is a while loop. So after some time, a certain of time, the while loop will check whether the system is shut down or not. So for this main method, this is the things that is the entry and the exit. This there are at least two threads is involved. Actually, the server contains multiple threads. This is the asynchronous system. So the server started, but the entire process need to wait until the server is shut down. So this is the typical code structure to start any asynchronous distributed system, or any concurrent system should be started in a similar manner. So this is if you have no experience to program any distributed system from scratch, I think maybe this pattern give you some idea. I think it's easy to understand. It's very simple, right? So first we need to start the server, and then just wait and check periodically whether the system is shut down or not. This is the first pattern. The first pattern have no any relation with any corresponding distributed perimeter API. So you can see it's one additional design pattern that is required, but it's not related with any existing distributed perimeter API. Here is I show a table here, and I think because for this class I spend much time talking. I plan to spend much time on how to program a system, not just talk about some ideas. Although until now we haven't show programming procedure yet, but I think this is my primary goal. In the following classes, for each class, I hope give you an example to program. So I do not want to spend much time here. This is the form I want to write some papers or articles or books to explain something clearly. This is my way to explain the code level design patterns. But I don't want to talk about this form, spend much time on that. So if you are interested, you can maybe you can access the GitHub website and get one ebook from there. This book is has not been published. I still upgrade the new version, and I also need to. I'm still working on some papers, articles. Maybe that form is explained in that documents. So here in this time, I do not want to spend as much time on that. So it's easy to understand. So I don't want to explain the starting point again. It's very easy to understand. So next time we can take a look at another pattern. It's called CS server. This is a name. The name is exactly the same as the its corresponding API, because we have talked about the API CS server, right? This is the first API, distributed perimeter API, and its corresponding design patterns is named as CS server. The acronym of this pattern is CSS. So this pattern is used to how to program a server API, CS server. In this pattern, we need to initialize something, because there are a lot of computing resources for a server, so we need to do some initialization. But for the real code, not only the computing resources for the distributed system should be initialized, though those resources for applications also need to be initialized here, because when the server is started, some of the computer resources on the servers on the application level should be initialized here. right? So the server is started, a lot of initializing tasks should be accomplished here. Dispose. When the server shut down, all the resources should be collected and disposed, right? So this for the server, this is the almost for each server, the same thing should be performed, right? We should complete all the tasks, dispose, initialization, right? So the code is, this is also the simple code, right? As a SOTA code is simplified code, so it's easy for you to understand. First, we need to start the server. There are two fields. The first you can use multiple instance if you like. For each server, maybe the server for one instance of server, CS server, you need to accomplish one primary task. For another server, maybe that server required to communicate with any other some clients. So there are different clients. Maybe different clients have different tasks. So you for convenience, for you to make it easy to manage the distributed system, maybe multiple instances can be established. One typical example is here. If you want to go through the code, you can first you open this project, right? And then you open this one. This is called chat server. In this case, there is two instances of the CS server, but for the first one, it's used to accomplish the goal of chatting. So there is a dispatcher here. The dispatcher is used to receive incoming chatting message and perform the chatting on the server side. But another dispatcher is called for this server. It has another dispatcher. It's called chat man. Man here means management. So it's a chatting manager server dispatcher. So that means this server is mainly focused on administration. So the administrator will interact with the server through this dispatcher. So for this case, there are two instances on the server side, right? So you can, if you like, you can also combine them together. It doesn't matter. I think it's but for cleanness, for the sake of clarity, maybe this one is better. So at least CS server is an instance class, right? Not a singleton. So you can create many instances if you need. Here, two instances are created. This is also singleton, right? Singleton means that this when you create a server, the server really should be singleton. So this is the one. This is a requirement for the CSS pattern. So singleton should be here, and then you need to create the code, the method. This is the method called stop. That means the server is stopped. So when the server stopped, this signal, the terminal signal should be set. So the entire process will know the server process is shut down. Then all the long-running threads or tasks can be terminated by checking this signal. So this signal is unique for the entire process on the server. Account registry, because this is the practical code, right? This is real code. So this is for chatting. So when the server is shut down, then the registry, the account registry, this is the application level code. The application level computing resources. so it should be disposed when the server is shut down. At last, the two instances of the server also should be stop. Start. When the server is starting, all the instances for the distributed system, you have two instances for that. The chatting server should be starting. The main server, the management server should be starting. And should be initialized. And then the server should be started here, right? So this is the pattern. So when you program the distributed system, the CS server is one of the things you need to follow. You just follow this code exactly. You don't need to invent anything new. You don't need to detect or check or trial any other solution. That because after long-term programming, I'm sure that I have ensured that this code is stable and this code is easy to be used by programmer. Just follow it. I can even generate the code in the near future because if all the developers follow the same structure to program the CS server, why can we generate the code? That's another idea. So at this time, when you program at the current version, you have to follow this pattern. Okay, this is also form. There's some fields, attributes I need to compare between different patterns. Server, okay. Next, server dispatcher. Server dispatcher is the most important API. We talked about that before. However, if you want to program with this pattern, how to do that? Okay, we can open the code. This is the demo. This is the sample code how we can create a server with server dispatcher. Right? There's a server dispatcher should be extended, and then there's some other related dispatchers for messages should be declared, and then all the dispatcher for message processing should be initialized, and then another part is to shut down all the dispatchers, and even the server dispatcher also need to be shut down. And for this method, it's required to process the incoming messages according to their type ID, right? So this is the code. We have seen that, but the reason I want to show you today, I just want to tell you, this structure is stable. It's almost fixed. You just follow that. You don't need to invent anything new. You just follow the code structure and program your system. It's a server dispatcher. You can see here, this is the same, but the code maybe looks simple. Notification dispatcher. When you program the notification, you also need to follow something. The notification dispatcher actually exists in server dispatcher. You can also say the notification dispatcher is one part of server dispatcher, really? And because it exists in here. But for the sake of clarity, I separate from the server dispatcher. I name a new dispatcher. It's called notification dispatcher here. When you create a dispatcher, here you just follow this code exactly, right? Its message should be exist, and thread and thread creator, and then you can initialize here with some parameters, and then you need to dispose it, and when the message is received, just follow this code to process its corresponding notification. It's a notification dispatcher. This code here. Follow it. Request dispatcher. Request dispatcher. Request dispatcher its acronym is RD. You can also say how to use it here. When you create a request dispatcher, or when you program this request dispatcher, the message, the stream, the response, the thread, the creator, you need to create all the stars before request dispatcher can be programmed. After that, initialize it, dispose it here, and then process incoming message in this way. All the things, all the structure is same. You can see here, this is the pseudocode. Notification queue. Notification queue actually is a thread, how to program a messaging-oriented thread. That's the essence of what a notification queue is. First, this is constructor, and then here is the run method because it's a thread, right? But this thread is different from the Java thread, the native Java thread, because it's actually the managed thread. How can it be managed? You just follow this pattern, then it become a managed thread. You just, but there's some difference, right? Notification is different. The processing code is different, but other code is the same, exactly same. You just actually you need to replace this line and replace this line if you want to design a notification queue or design a messaging thread to process other notifications. But whole structure, other code is the same. So why we call it a pattern. Sometimes I call it double well concurrency, DWC, because the typical structure for this managed thread or thread messaging thread have a two well structure, right? So you can follow this structure. So to program the code, because of the two while loop exists, so sometimes I call it DWC. It's a two nested while loops. This is the obvious structure for this system. Request queue. Request queue is also double while structure. You can see here, right? The difference is here. It thinks the response method is usually invoked after response is generated by within the line 31. In this line, the response is generated, but the line 33, the response is sent back to the server, to the client. This is the form. So those we can here take a look at this code. The code you must have seen it, but maybe you have not aware that's a fixed code. This is the stable code structure. If you in the future, if you want to create a new request queue or new request message processing thread, you need to replace this one, because this one is used to processing the incoming message and generate the response. This we can call it application interface. So all the applications should be performed here. Application level code, business logic, for example, should be performed here. And then you need to replace this one. You also need to replace the placeholder because you need to process any other messages. And then you need to send the response back to the client. So the code is stable. OMS is another type of code structure or data pattern. This is easy. This is very easy because it's actually a constructor. You just implement the constructor, default constructor. Then you don't need to worry about anything else. This is a table, the form to explain OMS. Notification queue. Notification queue is also a very simple design pattern. You just because this one is you just need to implement the interface. So when the interface is implement, just one method create notification thread instance need to be implemented. So you can because it's so simple. It's so simple. It's it can be hardly be claimed as a design pattern, but actually because the design pattern definition is not so restrict. So sometimes I would like to call this code is a design pattern. Yeah, although the code can also, if you use Eclipse later program this code, you can see all the code can be also even generate for this simple design patterns. This one, OMS, and the NQC, those code can even be generated by the Eclipse because it's so simple. Right? RQC is a request queue, stands for request queue creator. Yeah, it's very simple, right? It's exactly the same as simple as NQC. Just implement this method. That's enough. Remote reader. Okay, a singleton should be implemented and should be initialized, should be shut down here, and then maybe we can take a look at the request queue. Right, request queue. The creator. The stream is a stream, right? It's very easy to do that because this code can be generated by the Eclipse. And the creator is very easy. Just implement the interface. Okay, let's the server side is finished. I want to go through this lecture as soon as possible, as fast as possible. So that means we can start program. I like program. I don't want to talk only. Yeah. Read. This is a singleton. Initialize here, start down here, and send a request and get a response. Send another request, get another response. The code is simple. Synchronous remote eventer. They said you just follow this code to create a synchronous remote eventer. This you can. Its acronym is SRE. One notification, another notification. Dispose, initialize, IP pod is required, and then we can perform notification. Okay, that's the form. Asynchronous remote eventer. Asynchronous remote eventer. This is a send notification asynchronously. This code is a little bit difficult because you need to use thread pool. It performs concurrency and think the message should be processed asynchronously. Dispose, initialize, send one message. Just follow the code exactly. Okay, another one is a notification. I just mentioned at the beginning of this class, this notification, the corresponding of notification API is server message, the server message, and the other part for the data to be transmitted through the notification, you need to use in Java. You need to design some getters. Let us take a look at this. Getters. Multiple fields exist. You need to transmit the data from the client to the server. Then all the fields should be exposed through the getters. The server message should be extended, right? Okay. Request response. Actually, the same. In this case, the same. In the later classes, more complex message should be created. At this time, the request dispatcher notification should be extended by other. The server message may also be derived. Some more complicated messages should be created. So at that time, the patterns, new patterns may be available, or at least the request response and the notification have different multiple forms. For this simple case, for this distributed primitives, the request response and notification actually the same thing. You see, exactly the same code, right? The format and the code structure is the same. But for the sake of clarity as well, I name them in different way. At least this is the two message. The pair request response is the one pair of message. When you program request, you must at the same time you must implement a response as well, right? For the notification, this is a single one. So that's why I name them into different design patterns. Okay, I think all the patterns are explained, and maybe I think you must have seen the code before, but so for this class I talk about very fast, but in the later time, maybe until now you haven't be aware why those patterns are so important, right? So I think you can understand the major ideas clearly and deeply in the future classes. When you program this code, you can see when we program with the patterns, the distributed primitive patterns are very easy and easily to be used. It saves you a lot of effort. And the more important, I have a concept, or I have one. The Graph3 has one fundamental technique called SPRA. That means any distributed system have the homogeneous code level design patterns. That's a very important progress in distributed system programming from my point of view. You know, distributed systems are very, very complicated. If so, the code structure should be heterogeneous. This seem to be true, right? But according to my experience, I think it's not heterogeneous, it's homogeneous. So if you have understand, you can program with all these patterns rapidly, conveniently, and efficiently. That means it's possible for you to program any system in the same way. That's very important issue, right? So at least if you do want for complex system, maybe the effort is high. The burden may be the coding burden may be also heavy. However, if the patterns are similar, if the patterns are homogeneous, the machine can generate those code for you. If you just specify some difference between, just specify the difference. However, the system can be generated quickly. Yeah, the code generation is computer is very fast. It just follow the same pattern to generate code. Follow same pattern to generate, different system. That's why I want to spend some time to discuss those design patterns. I hope you can understand this step by step. Even you don't understand, it doesn't matter. I think you can like this system programming. And I will show you how to do that in the next classes. This is the next topic of next class. Programming the TNCS with distributed primitives. This is what we're talking. I want to talk next time. It should be like class 3, right? So let us talk about that next time. And even you haven't believe what I have declared in the previous classes. I think programming is the real, is the final goal, right? If you can enjoy the rapidness, the convenience, the efficiency of programming distributed system with script-free, that's more important than any ideas. Okay, that's all for today. Thank you so much.